Hello everyone. This is the part 8 of Unit 6. In this video, we will study about different hierarchical deadlock detection algorithms. That is, Menasce-Muntz algorithm and Ho-Ramamoorthy's algorithm. We will study these two algorithms one by one. At first, Menasce-Muntz algorithm. In Menasce-Muntz algorithm, sites are organized in tree structure. Leaf controllers manage local weight for graph. Intermediate controllers are responsible for deadlock detection. Each parent node maintains a global weight for graph, that is, union of weight for graphs of its children. Changes are propagated upward either continuously or periodically. Now, Ho-Ramamoorthy's algorithm. In a Ho-Ramamoorthy's algorithm, sites are grouped into disjoint clusters. This algorithm uses only two levels. That is, master control node and cluster control nodes. Master control site chooses a cluster control site for each cluster. Cluster control site collects status tables from its cluster and uses Ho-Ramamoorthy one-phase algorithm to detect deadlock in cluster. All cluster control sites then forward their status information and weight for graph to the master control site, which combines all information into a global weight for graph and searches it for cycles. Here, cluster control site detect deadlock in cluster, and master control site detect deadlock between clusters. In this example, there are 3 clusters and each clusters have their own processes. All the clusters are joined on the master control site. This master control site shows as a cluster control site from each clusters, which collects status tables from its cluster. This cluster control site uses Ho-Ramamoorthy one-phase algorithm to detect deadlock in cluster. All these cluster control sites forward their information and weight for graph of individual cluster to master control site. This master control site will combines all the individuals' information of clusters and forms global weight for graph. And then, it searches for the cycles. If there is cycle, then deadlock is detected, otherwise there is no deadlock. This is the example of Ho-Ramamoorthy's algorithm.